Hello everyone. In Geometry for CAT series, we are discussing circles. And till now, we have discussed almost all the concepts based on circles and solved so many amazing problems. So if you haven't watched those videos, then I will suggest you watch them first and then come to this one. Okay? So let's discuss our first problem today. A circle is inscribed inside a quadrilateral ABCD such that it touches all the sides of the quadrilateral at P, Q, R, and S. Which of the following is correct? So, there is a quadrilateral. Let's say this is something like this with vertices A, B, C, and D. There is a circle inside this quadrilateral which touches all the four sides at vertices P, Q, R, and S. So we need to find which one of these given statements are correct. AB plus BC is equal to AB plus BC is equal to CD plus AD, or AC plus BD, AC plus BD, which is equal to AB plus BC plus CD plus DA, or whichever of these are correct. So first thing that comes to my mind whenever I see a circle inscribed in a random quadrilateral, that if I use the concept that tangent drawn from a point on a same circle are always equal, I can say if SD is equal to X, DR is also equal to X. If RC is equal to Y, CQ is also Y. If BQ is equal to Z, PB is also equal to Z. And if AP is equal to W, then AS is also equal to W. Now, look at this closely. Okay, what do you see? Can I say that if I take the sum of opposite sides AB plus CD, AB plus CD, what do I get is W plus X plus Y plus Z. And similarly, if I take another pair of opposite sides, which is AD plus, okay, this was supposed to be AB plus CD, not BC. AB plus CD, and in that case it will be AD plus BC is equal to, this will be equal to again W plus X plus Y plus Z, right? So what do we see? We see that AB plus CD is equal to AD plus BC. AB plus CD is equal to AB plus BC. Where do you see that? So AB plus CD, BC plus AD. Yes, that is correct. Option C. So you can remember this concept that in any quadrilateral, if a circle is inscribed, then this is the relation between the sides of that quadrilateral, that sum of pair of opposite sides are always equal. Now the next question, it says in the given figure, radius of the quarter circle is square root of 35 centimeter. Then find the side of the square. We need to find the side of the square. Now can we say that if this is a square PQRS, then if length I take OP is nothing but the center, right? So because PQRS is a square, this will be a symmetric figure. PQ, if PQ is X, OS will also be X. And as this is a quarter circle, angle SOP will be 90 degree, and so PS, which is side length of this square, will be X root 2. Now if I join Q and S, which is nothing but the diagonal of this square, we know that this angle is 45 degree, this angle is also 45 degree, overall this angle will be 90 degree. So in that case, I can join OQ and we get a right angle triangle OSQSO, where QS is nothing but square root of side length, which is 2x. Right, this will be the side length of the square, sorry, not side length, the diagonal of this square. So now using the Pythagoras theorem in triangle OQS, can we say OQ is nothing but the radius, so x square plus 2x whole square is equal to OQ square, which is equal to square root of 35 whole square, or 5x square is equal to 35, or x square is equal to 7, or x is equal to square root of 7. What we need to find is length of this square, side length of this square, which is PS. We can say x root 2 will be equal to square root of 14 centimeter, and so our answer is option D, square root of 14 centimeter. Now another amazing question, it says in the given diagram CT is the tangent at C, making an angle of 30 degree with CD. This angle is 30 degree. O is the center of the circle, CD is equal to 8. What is the area of the triangle OBC? So what do we know about chord and tangent? That angle made by a chord, with the tangent is same as angle made by this chord on the circumference, right? So if I join AD, that angle will also be 30 degree, but is that required? Let's see. First of all, if this angle is 30 degree and I join, right, so OC is the radius, right? Can I say this whole angle will be 90 degree? The radius is always perpendicular to the tangent, right? So if this angle is 90 degree, can I say that angle OCB, this angle will be 60 degree? And if this angle is 60 degree, it's given that CD is equal to 8 centimeter, OB is perpendicular. So if you draw a perpendicular length from center to any of the chord, it bisects, right? So we can say BC is equal to BD. In that case, BC will be equal to 4. Can we say BC will be equal to half of CD, which is 4 centimeter. Now using 30, 60, 90 triangle, can I say the side length opposite to 30 degree is 4, then the side length opposite to 60 degree is 4 root 3. So OB is equal to 4 root 3. What will be the area of triangle OBC? This will be equal to half of BC, which is equal to 4, into OB, which is equal to 4 root 3. So 2 times we get 8 root 3 centimeter square. So our answer is option A. Now next question says in the given figure find the radius of the smaller circle if radius of the two larger circle are 16 and 25 centimeter. So remember, in these kind of situation, if radius of one of the circle is x, another circle is z, and the sandwiched circle is y, then the radius, the relation between their radius is given by square root of 1 upon y is equal to 1 upon square root of x plus 1 upon square root of z. Now we can simply use it, that 1 upon square root of y is equal to 1 upon square root of 16 will be 4 plus square root of 25 will be 5, or we can say 1 upon square root of y is equal to, this will be 9 upon 20, or y will be equal to 400 upon 81. So this value is approximate 5, right? Just less than 5. If you check option A, that's closest to 5, and that is our answer. Or you can also choose to calculate it, but that is not required here. Next question, it says in the given figure, find the area of the shaded region. We need to find the area of this shaded region, where this is a semicircle, this is also a semicircle, and this is a quarter circle. Okay, so if I say this is O, A and B, the diameter is 14 centimeter. Now let's talk about the center of these two semicircle. If I join this will be radius R, which is nothing but 7. So can I say this is 7, right? And then if I join this will also be 7. Now what's left? Again, we are left with quarter circle here. We are left with this quarter circle, and this will become a square because this is also radius 7, this is also radius 7. So what we need to find is area of this shaded region. So area of this shaded quarter circle will be equal to, so radius is 14, so 1 by 4 into pi into 14 square minus area of this quarter circle will be 1 by 4 into pi into 7 square, and there are two such quarter circle plus 7 square. So this will be the required area, the area of this shaded region, right? So from there, if I use pi is equal to 22 by 7, right? What will be the value of this expression? So 196 by 4 is 49. So 49 into 22 by 7 minus, this is 2 times, let's use this, 22 by 7 into 1 by 2 into 49 plus 49. 2 times 11, 7 times, this will be equal to 7 times, so 154 minus 11 into 7, 77 plus 50, 127. So remove 126. So this will be equal to 28 centimeter square. So that will be the area of this shaded region. Now, one very interesting part is, if question is asked, what will be the area of this region? This leaf. So area of this leaf is same as area of this shaded region, which is also 28 centimeter square. Okay. So with that, we are done with this session. I hope you liked all the questions and their solutions.